Hello everyone, it's Catherine Chahar here, and today we're going to be looking at geometry in upper key stage 2. So let's start off with year 5. So in year 5, children will be expected to solve problems about shapes by using their knowledge of geometric properties, and that includes drawing and measuring angles in degrees, finding missing angles on a point, on a line and in rectangles, as well as describing translations and reflections of shapes on 4 quadrant coordinate grids. So let's start off by recapping our angles. So in the previous year groups, we looked at acute, right, obtuse and straight angles. But in year 5, we're now going to be introducing reflex angles, which are greater than 180 degrees, and full rotations, which we already know are 360 degrees. But now we need to be able to draw and measure angles. So let's start off by looking at how to use a protractor. So when you've got a protractor, it might be solid or it might have a space in the middle. And we start off by placing the cross or circle right in the centre of the protractor at the point or the vertex of the angle that we are measuring. So we need one of the lines to be along, or the bottom line to be along the bottom line on the protractor. And then we use the scale starting at 0 on the outer side to measure where the next line meets. And we count the degrees, we count the degree lines carefully. Now to draw an angle using a protractor, we first start off by drawing a line. We then mark a point at the end of either side of the line. We put the point that we've just drawn in the centre dot of our protractor, and we measure by counting up the outside the number of degrees. So for example, if we're measuring to 40 degrees, we would put a dot at 40 degrees on the protractor. We then connect the dot to the centre point that we started with, and that internal angle will then be 40 degrees. Now we look at angles on a point, on a line and within a rectangle. So if we start off by looking at the left, we can see we already know the angles on a straight line are 180 degrees. So we would use our protractor to measure each of the 3 angles on the first line, A, B and C, to find out what they would be. Now we know that as long as we add them all together, they should not be larger than 180 degrees, but they should be 180 degrees exactly. And the same for the second shape at the bottom there. We know that the full rotation is 360 degrees. So when we check our work and add up A, B, C and D, we need to know that they add up to a total of 360 degrees. Now we don't always have to have a protractor to show us the size of angles. So if we look at the second diagram in the middle where we've got the angles within a rectangle, we can see that there's got a cross in the middle and that one of the angles has been marked at 67 degrees. And we want to find out what angle A is. Well, if the angle that's marked is 67 degrees, we know that the opposite angle, let's call it B, is also 67 degrees. So we can add that up together and that will give us 134. We know that the total angles within that point would make up 360. So we need to get our 360 and subtract the 134 that we have. And that leaves us with 226. So we know that angle A and the angle opposite will be worth 226 degrees. But there's 2 angles and they'll both be the same, so we divide it by 2. So we do 226 divided by 2 gives us 113. So we know that angle A is 113 degrees. Now we didn't need a protractor to do that, we'd use our mathematical knowledge of internal angles. Now again, looking at further shapes, we know that all rectangles have straight sides marking up 2 pairs of parallel lines. We know they've got 4 corners, 4 right angles, and that the angles in all rectangles add up to 360. And we need to remember and use that knowledge when working it out. So let's start off by looking at the shape at the top. So we want to find out what angle B is. We know that angles within a square or within a rectangle or around a central point will be 360 degrees. So we have our 2 60-degree triangles, which we add together to give us 120. We know that we need to subtract it from 360, so we can see that angle B is 240 degrees. Now the bottom diagram looks a little bit more complicated. I will use my arrow or my pen to point at this to make it a little bit easier. So if we look over here on the side, we've got this angle here we know it's 90 degrees, and we know that angles on a straight line here are 180. So when we've split the shape across, we know that this angle and this angle were 90 degrees, but it's been split down the middle equally. So we know that those two angles are now worth 45 degrees. And we know that angles within a triangle, okay, we know that they add up to 180. So we've got 90 add 45, and the other angle therefore must be 45. So we can identify that that and that angle are 45 degrees. Now previously we identified here angles on a straight line are 180. So if we know that this angle is 45 and this angle add this angle must have been 180, we can simply subtract 45 from 180 to give us 135. And it's as simple as that. All it takes is a little bit of time to work it out and use your knowledge of angles on a straight line, right angles, angles around a point. Let's move on to the next slide. So now we're going to be looking at polygons. So we know that a polygon is a shape with straight sides and it's got 3 or more straight sides. We know that if all the sides are the same length, then that shape is regular. Regular shapes have equal sides in length and equal angles. So a regular polygon can be an example as here. So we've got an equilateral triangle, squares, a regular pentagon, a regular hexagon, a regular heptagon, or a regular octagon. Now it's important, for example, on the pentagon, that if all the sides are the same length and all the internal angles are the same size, we must put the word regular in front of it because, of course, a pentagon simply means a shape with 5 sides, so you can have an irregular as well. So let's look at irregular polygons. So again, polygons shape with 3 sides, straight sides or more. But if any of the sides are different length, the shape is irregular. So if we look at the example of the triangles, we can see that the right angle triangle, isosceles and scalene triangle all have sides that are different lengths. So therefore they can be called irregular triangles. If we look on the right, for example, at the irregular hexagon, we know that it's got 6 sides, but the sides aren't the same length and the internal angles aren't the same length, so therefore we can call it irregular. Looking now at coordinate planes. Now when we looked at coordinates in year 4, we looked at the first quadrant. And when you are looking in year 5 and year 6, we'll be looking at the 4 coordinate planes. So we start off in quadrant 1, and they are all both pluses. There is no minus on your coordinates. And then we move anti-clockwise. So quadrant 2 is to the left. So we've still got the plus on the y-axis and the minus numbers on the x-axis. Going down below there, we've got quadrant 3. Both axes are minus. And moving across to the right there on quadrant 4 means that the x-axis is plus and the y-axis is minus. So it's just important to remember that when we talked about the 4 quadrants, we go anti-clockwise. So again, we're going to be looking at describing translations, rotations and reflections of shapes, but this time it will be within the 4 quadrants. So we already know that translations simply mean moving the shape from one space to another. So if we look at the translation of the triangle that's drawn on the 2nd quadrant, all we need to do is to simply pick a point on that triangle and count how many squares it's been moved by. So for example, if I was to start at point C, I can see that it's moved 1, 2, 3, 4, 5, 6 down. And I can double check that all the points have been moved down by 6. I can check on point B to B and point A to point A. So we can simply describe this triangle as being translated 6 points down. Looking at rotations. So a rotation is where we move a shape or a figure around a specific point. So if we look at the bottom diagram, we can see that the rectangle has been translated around point A. The whole shape simply moves around that point. So it's as if we're picking it up and moving it around. And we can see that that has been a rotation of 90 degrees. It's a quarter turn. Now, if we look at the diagram on the right, we can see that the shape has been rotated, but it's at a point away from the shape, so it's not a point that's on the shape. So in this term, the centre of rotation is point 0 right in the middle. So it's important that when we're looking at rotations, that the point of rotation doesn't have to be on the shape. The centre of rotation can be on the graph. Looking at reflections, we know that reflection is simply a flip of a shape. It's a figure that gives a mirror image. Now, the reflection can be on the line of the shape, or it can be a space away. So, for example, if we look at the grid on the right, we can see that the red shape has been reflected along the y-axis, and therefore there's been a gap between the shape and between the axes. And it's important as if there's a gap on one side, there is a gap on the other. So moving on to year 6 now. So in year 6, children will be able to construct shapes accurately, be able to find unknown angles in triangles, quadrilaterals and regular polygons. And this includes drawing 2D shapes from given dimensions and angles, building 3D shapes from nets. You need to be able to illustrate and name parts of a circle, as well as drawing, translating, reflecting shapes in the axes of a coordinate grid. So let's look at drawing 2D shapes. So first of all, our 2D shapes may be a little bit more complicated than they were in previous year groups, and we need to remember how to use a protractor to draw angles, because when we're given our angles, we need to be able to make sure they're drawn accurately. So this is an example of how we can draw a shape. If we look at the instructions on the left, so we draw a line AB in 5 centimetres length. We then at A measure an angle of 120 degrees and a line of 4 centimetres. Mark this D. Then at point B, we measure an angle of 60 degrees and a line of 4 centimetres. Mark this C. And finally, it asks us to join C and D and label angles C and D and line CD. And then it asks what shape has been drawn. So the important point is when we're drawing a 2D shape using this process is that we simply have to be methodical and go around in the right order and make sure children don't rush. Looking at 3D shapes now. Now, in our previous year groups, we did build some simple 3D shapes using nets, and we also used lolly sticks and straws, but we're going to be looking at 3D shapes based on nets. So more complicated shapes have slightly more complicated nets, and a 3D shape can have multiple nets. So if you look at the diagram on the right, all of those nets are the net of a cube. There will be one that you will see most commonly, but all of them fold up to make a cube. And children also need to be able to recognise a 3D shape based off their net. So for example, if you look over on the left and we can see the cylinder, a child needs to know that if that is a net of a cylinder, when it's folded up, it will be able to make a cylinder. And they need to be able to do that without physically making it as well. Obviously, we'll start off by physically making it, but they need to be able to remember that. Looking at identifying our missing angles. So we need to use our knowledge of angles in shapes. So we already know that any angles in a triangle is 180 degrees and any angles in a quadrilateral add up to 360 degrees. So if we remember those two key facts, we can work out the missing angles. So now we're going to be looking at missing angles or lines within a quadrilateral. So we start by looking at the trapezium on the left. Get my pointer out here. I've put there that adjacent or opposite angles at either end of the non-parallel lines in a trapezium add up to 180 degrees. So we know from previous part of the video that this and this arrow symbolises that they are parallel. So we want to be looking at the non-parallel lines. So we want to be looking at this side and this side. So we know that if opposite angles at the end of a non-parallel side, they will add up to 180. So this angle and this angle is 180 degrees. So all we need to simply do is have 180 degrees, subtract this angle of 65, which gives us 115. looking at the trapezium on the parallelogram, on the right, we can see the opposite angles on the same line in a parallelogram add up to 180. So for example, this angle and this angle, they're on the same line, they will add up to 180. So the same on this side, we've got this angle and our missing angle, they're on the same line, so we know that it's all we need to do is 180, subtract 76, which gives us 104. Move on to the next slide. So looking lastly at parts of a circle. So there are 3 key points that we need to know in year 6 for parts of a circle. We need to know that a diameter of a circle is the length of a line straight through the centre from one edge of the circle to the other. We need to know that the radius is the distance from the centre point to the outer edge, and we simply need to know that the circumference is the total distance around the edge of the circle. Thank you very much for listening to the third part of this week's training session on Key Stage 2 Geometry. As always, if you've got any questions, please email me on my new email address on here. And don't forget to complete the form at the end to show that you completed your training. Thank you very much.